Okay, here is our topic. And our objective is this. And what this means is the thing that tells us whether or not something is thermodynamically favored. Favored is negative. Um, but something's happening that's not it's not happening, or at least at an appreciable rate. Like you think two things are going to work, but they don't. And this video is about why. Um, Another way to think of this, I use that idea that the universe wants it to happen in terms of its delta G, but we're going to highlight this thing called kinetic control. Something's going on that's preventing it. All right. We're going to explore one phenomenon. You see this graphite, all right? And you see this diamond. In terms of its Gibbs free energy, if you look at these values, you'll notice that uh, diamond's value is greater, and graphite's the elemental state or standard state of carbon. Therefore, if I were to calculate the Gibbs free energy of this change, I'd get a negative number. So this is telling me that it's thermodynamically favorable, but it doesn't happen. Diamonds stay around for a long time. I read this fact from one website. It said if you had like 1 gram of it, it would take a billion years for it to change. So it's very, very slow. Another example of this is sugar, sucrose, and this is the combustion of sugar. If I were to calculate my Gibbs free energy, here are my values that I got. That's this. That's a ton of energy, but why doesn't it happen? Sugar stays on the shelf for a really long time. Well, so here's our phenomena, right? And there's our proof. Here's the other one, and there's our proof. The reason being is there's a high activation energy for these reactions. Therefore, they don't want to they don't well not that they don't want to react, they can't react. There's too much energy they need. All right? We call this kinetic control. Now I want to just draw it too for you. Um, if I had diamond and I drew it, I have a huge bump, huge hill I got to climb, and it's too big. The diamond doesn't have the energy readily available to do it. It's way too big, and it's not the amount of energy you can get it from like whacking a diamond against something. All right. Now, just one reminder: you could put a catalyst or change the reaction profile by changing the catalyst, not changing by addition of a catalyst, but this doesn't affect your delta G. All right. You can affect the rate, but you can't affect the delta G. And I want to illustrate that a little more deeply. Your reaction coordinate, your energy, your reaction profile. All right, we got this. This part here is there. This part of the reaction profile is really about kinetics, how the reaction happens, elemental steps, that kind of thing. Where thermodynamics is really concerned about the first and last, or initial and final. All right. Thank you, and I hope that's been helpful. And now you can understand why sugar and why diamonds stay around a long time. Oh, here are my sources. I got the joke from that and some of the facts about diamond from these sources, and I got the that image from this last one. All right, thanks a lot.